So let's give them some time to join so that we can start. So let us give them the next. Let's start at 17. Good morning, good evening, sorry, once more. So confirm if I'm audible before we proceed. So thank you. So, so yesterday we were to do the lab at our own pace. Anyone who did the lab and maybe any challenges you faced, so that we have a look at them before we proceed on today's.
Well, I didn't do the lab, but I was able to install Git on my Linux thing. It was the network, like it was not connected to internet, so that's why it was not installing.
That's okay. That's great. So it's okay. We'll pick it from where we left. That means they will be looking at on today's work, which is branching and collaboration. Um, Branching and collaboration. If we can start with the collaboration itself, it's one of the major aspect of DevOps in any organization or in any setup. And the branching is one of the things that will be able us to achieve the collaboration. Because from yesterday's work, when we initiated the repository with Git init, the terminal could show us that the branch that has been initiated, which is the default branch, is master. But from the master, you can create other branches. And those other branches are the ones that will assist us to do collaboration in a way that maybe we have more than one developer working on the same project. You can have branches for each and every developer basing on the main or master branch. Then we'll be merging our code to the main branch. So you can start with the branching basics. So we'll try to understand what is a branch. So in Git, a branch is an independent line of development, essentially a lightweight, movable point to a commit. So one aspect of a branch is that it's a lightweight and it's a movable pointer to a commit. So from that statement alone, we can understand that different branches can have different commits. So maybe you have a master and the last commit is maybe we updated the readme.file. Then we create a branch from commit, then we do another commit on that branch. That means these branches are very independent, but one, it has commit on the other, but the other one doesn't commit on this new branch. So that means one branch has more commits, or it's ahead of the other. So but also it's an independent line of development. So that means the feature branch, if we can call it, does not depend entirely on the main branch. It's okay. Maybe we created the branch from the main branch, but now we are working on this branch independently in a way that we can push code to this without affecting the other branch. And in case there is any code that will be pushed on the main branch, our branch, at least at the moment, will not be affected in any way until the time we will want to merge the code. So why do we need branches in DevOps? So the branches in DevOps first is for feature development, bug fixes, and experiments. As we saw yesterday, one aspect of Git is to do experimentation, but also for bug fixes. You deployed your code to production, it was working well, then something happens. and all of a sudden now, maybe users are not able to perform to get certain functionality. Let's say your application was just as a messaging app, but now user can send a message, but it's not able to send maybe a video, or not able to send a picture, a photo, and all. So that means we'll create a branch based on the main branch, which is running on production, and check on that issue and fix. And also on a feature development, maybe a branch, a software was already on production. It's a messaging app. So currently the messaging app is able to send pictures, send the normal text, and send maybe a video. But now you want to add a functionality for a call, maybe a video call and audio call. Then from that branch, you can create a feature branch to do the development of that feature, which will be including the video call and the audio call. So it's one aspect is also isolating the changes before merging. So as we are developing this feature, or so that means these changes, or it's a bug fix. So that means these changes that we are doing currently, they're not on the main branch. So we isolate these changes until we are satisfied that these changes now can go to production. We can merge the branch to the main or the master branch. And also branch, it support release strategies. So on release strategies, maybe we have, according to our policy or our setup, is that only a release branch should run a code that will be going to production. So that means all our code that is running on production, its reference is on the release branch. Then that means we don't expect any development work to be done on the release branch. Any development work can be done on any other branch, but not on, at least on the release branch. So that means in case we see a code on release branch, that means that code will be deployed, or it's a code that is going to be deployed and running on the production environment. So some of the common commands that you can run on branching is, one is the git branch. So when you write a git branch, you'll be listing the local branches, because now we've not yet pushed our code to the remote repository. So we're able to list the branches that are on the local machine. So then we have a git branch feature X in case we want to create a new branch. So we'll use that command, git branch feature X. So then git checkout feature X, we've created the branch. Now we want to switch to that branch. So we git checkout. Or you can combine the feature of creating a branch and checking out to the new branch. So you'll say git checkout branch feature X. So the new syntax to switch, you can say git switch feature X. So you'll be switching the branches. So in case you want to create and switch a branch, then you'll say git switch -c feature X. But the common one used is the git checkout -b feature X to create and to switch, or git branch to git branch, then the name of the branch. So after we've created our branch, now we have more than one branch, and each and every branch has code, and now we want this code to be merged together. So in merging this code, we are facing one issue that is very common in most cases, where a repository is a public repository, not a public, but a branch is a public branch. The repository can be a private, but the number of developers working on the same repository, so they'll be doing changes on their branches and committing those changes to the main branch. So merging those changes. So when you commit your changes to your branch, then you want to merge these changes to the main branch now. That's what we call merging. But during the merging now, you'll find that you did, by the time you clone the repository and got those changes, maybe you had only two commits. Now your fellow developers have pushed those changes, maybe there are now 10 commits on that branch. That means you are behind because there's so many commits that you don't have on your branch, and this will cause a conflict. So the conflict will happen that the same file has changes in two different branches. So let's say it's a readme, and your readme, it has my project and this content, but someone else has edited that content, either has added content or has deleted some content on that file. That means the content has changed, and also maybe on your end you've done some alteration or some other commits on that file. When you're going to merge these changes to the main branch or to the branch that the others have made the changes, you will encounter the conflict because these are two different commits that are going to the same, they are affecting the same file, and they need to be on the same branch. So that's why you'll face the conflict, and you need to resolve this conflict. So Git merge will combine multiple sequences of commits into a unified history. So there were already changes on that. There are already commits on that branch. You have your commits on your new branch. Now you want these commits to be added to the base branch. So a merge is a standard merge will take each commit in the branch being merged and add them to the history of the base branch on the timestamp when they were created. So as any other thing, merge the standard merge, because we have a merge is just a standard merge. It has its pros and its cons. So it's the most disruptive because what this will do is that it will take all the merges in case you had merge 1, merge 2, merge 3 on the main branch, and now you have merge A, B, C, D on your feature branch. Then it will need to take this A, B, C, D and merge them to the new branch, not as a one commit, but as 3 different commits. So that's why you can see here it says the base branch, it will take each commit in the branch being merged. So it will take all the commits and take them there with their timestamp and their commit messages. So prose is most disruptive, and verbal history tells us exactly when things happened, helps give the best context about the code changes, because it will take each and every commit. It will not combine all the commits into one merge commit and commit it to the base branch. But it also allows us to see the graph when the branches were made using the git log, one line or graph, which help us to understand why the changes were made and when. It also allows us to see each commit that made up to the eventual merge changes, no loss of granularity. The granularity here, what we are talking about is that each commit is able to be tracked, because you can have maybe 10 commits, and when you are going to do the merge, you combine all these commits to one commit and you do your changes. So someone else on the new branch, this will be seen as a one commit, but from the source branch, these are maybe 10 different commits. So the granularity there will be maintained. So cons is that most of the time it's seen as messy, as they are empty and only really there for historical reasons. can be essentially confusing if you're trying to revert to a set of changes. Yeah, because you have so many commits, but these commits, maybe it was just a commit of maybe fixing, maybe it was a comment or just a syntax error. So on this syntax error, you'll not have really a something sensible you'll be saying you'll be fixing. Maybe you are trying to, you forgot to add a semicolon, but now because you forgot to add that semicolon, your commit, even if you say I added a semicolon, but you added a semicolon here, why did you added the semicolon? You'll not write the whole message. So it's like this commit is here, but it's not sensible enough. But also it can end up having complex graph or previous branches that's more difficult to read because you have all the commits from the source branches. So all the commits, so let's say you have 3 developers, these 3 developers, each and everyone was working on different branches, and all the commits now have been added to the new branches. So following that graph can be very complicated. So this is the graphical view of how it is. So you can see here we are. So you had your commit 1, commit 2, and when you are at commit 2, you created a branch. The branch has a commit A, commit B, commit C. But during that time also, and other commits were done on this base branch. So there was commit 3, commit 4, commit 5, and then there is this commit which is a merge pull request commit. So when you want to merge now, we'll take all these commits and be inserted where it belongs depending on the timestamp. So after commit 2 is when you created your commit A. So it will come between 2 and 3, and commit B will come between 3 and 4 because at that time it was created. But also on that day of commit, because you'll be resolving this conflict, you'll have a commit message. So that commit will come at the end. So that means the other one also need to pull these changes and insert the commit. So you might find also another person has commits between 5 and C that will be having a commit. So that's how the standard merge looks like. Then we have the fast forward, and the fast forward is when the base branch has no new commit since the future branch was created. So Git uses a fast forward approach. So by default, the Git uses the fast forward approach to do the changes. So you have your base branch, you create a branch, but we can use the example here. So by the time you want to do the commits, you may find that the last commit was commit 2. So now your commit will take it from here. So just add this commit after commit 2. So there's no any other commits that were done, but we'll see its graph the way it looks like. So this keeps the history clean, but it also allows us to see each commit that made up to the eventually merge changes, no loss of granularity also. But this can only be done when the branch hasn't had any new commits, which is very rare on a shared repository, because you can say that a branch that is a repository that is shared, you will only, when you clone it, create your branch, no any new commit that will be done on that branch. It also can be seen as in an accurate view of history, as it hasn't captured the branch or a branch was created or when it was merged. Yeah, because there is no any conflict, so that means you'll not find any issues with conflict those changes, and say maybe do a commit a merge commit on it, because where you left it is where you found the last commit is. So you can see in this way. So on our last graphic view, you could see there's a commit message, but on this, there's no commit message because the branch is clean. We left it at, and we did our commit A, commit B, commit C, and now we've come to merge our commit. We did not resolve any conflict there. So our branch is very clean. But another thing is the squash and merge. And the squash takes all the commits in the branch A, B, C and merge them into one commit. And that commit then is added to the history. But none of the commits that made up the branch are preserved. So unlike the standard merge or the fast forward, on the squash and merge, it will take all the commits that you did. So it will take A, B, C, and make it as a single commit and commit it to the base branch. So it keeps a clean history, can look a single commit to see full piece of work rather than shifting through multiple commits in a log. Cons, this one is losing the granularity. So any useful detail in the commits that made up the branch is lost, as are any interesting decision or changes in logic etc captured during the development process. So maybe you did each and every commit, it had message, but then in this case, maybe you are fixing a password reset and you fix it well, then you did that commit, then the password reset commit will be lost. Maybe you are fixing timeout, then that timeout issue or commit will be lost, because here you have only a single commit of the merge. So this is how it looks like. So it will take all this A, B, C, and it will use it as a single commit and push it here. Are we good on the types of merges we have before we check on the conflict resolution? So the conflict resolution, so the merge conflicts occur when the same part of the file change differently in both branches. Yeah, as I have said, you had a readme, then the readme, it had just basic, this is my project, but on your side you said you added a part maybe to say what will be to explain your change. Also another person add a part to explain the functionality that you'll be working on. So that means when you're trying to merge this, it will bring the conflict because there are changes that you don't have, and also the other guy has changes that there are changes that he or she don't have on his side. So a conflict in Git marks a conflict in a file like this. So we have a head version on the main, then we have the version on the feature. So then that's when you will decide which one do you want to keep. You want to keep what is coming, or do you want to keep what is here? When you you resolve these conflicts manually on your IDE, you'll be able to see. You choose either the incoming one or the current. So you choose which one do I keep, so that you get all the commits. So the resolution steps: edit file to keep the desired changes, remove conflict makers, then you git add the resolved file after you've resolved all the issues, then now you git you git commit. So once you commit, then you complete the merge. So there are tools that can assist you to do. Yes.
About conflict resolution, I've only
Yes.
done them in the GitHub repo, like GitHub repository. So how do you do it? Let's say if you do a merge in the terminal, does a Vim file, the Vim editor pop up when you want to resolve?
So let's say you're using an editor. The editor that I've used on locally, I've used an editor like VS Code. So in VS Code, let's say you have your repository and there is you want to push. So if you want to push and there's conflicts, you'll not be able to push. You'll get that. You need to pull first. So before you pull, then because you see a pull will come and it'll come and write your history or you write your commits, but you need you fetch. Then after you fetch now, you'll need to merge these two, or maybe you are doing it not on that branch but on a different branch through the merge. Now you have the base branch, which is main, then you have the feature branch. Now you will check out to main, then pull from main. So you get the changes that are removed, maybe other developer pushed on main. Now you'll come to, you'll check out back to your feature branch, then you'll say git merge main. So once you git merge main, on your left, you'll see that there is conflict that has been the main branch has brought. So you'll be able to see with these marks on the VS Code. On Vim, I have not worked it on Vim to see how the merge will look like, but on IDE like VS Code, IDE like net, is it the one for IntelliJ? IDE like IntelliJ, able to see this, so able to resolve it on IDE before you push it on GitHub.
Oh, okay. So VS Code, let's say it will just show those conflicts.
I'll show you the conflicts, so now you can choose which one to keep and which one to discard.
Okay, I understand. Okay,
Yeah.
thank you.
So now we are going to the remote repositories. Yesterday we did until we commit our we did the 3 stages, which is the local, which is the working directory, the staging, and the commit section that we've committed our code. Now after commit, we still have our code on local machine. Now we need to push this code to the remote repositories. So that's the part that we'll be looking at as from now. So to get the repository, you'll need to do a git clone. So let's create a repository so that we'll be working with this. At least we'll be seeing what we are doing. So let me switch to GitHub. So you can create a new repository. So the name of the repository, let's just utilize this one, the one we initialized. So the one we initialized yesterday, you can just use that as the name of the repository. So we can create this repository. So if you want to clone this repository, that's where you can come and say git clone. So if not yet want to use it here, let's say on the Linux demo, let's clone it here. So git clone. So you appear you have cloned an empty repository. So you can see here it is git DevOps. That's how you can clean your repository. Then you can cd to the new repository. So now we need to manage the remotes. That's the part to clone. But managing the remote, so like where we did yesterday. So when you create the repository, then you can come and say git remote v to show the remote URLs. So if you don't have remote URLs, you don't expect to see anything. So if you want to add the remote URL on your initialized repository on your local machine, now you're using the git remote add origin URL. So this one will be adding the remote. Then maybe you want to rename the origin. So you just git remote rename origin upstream. So in case you want to fetch, so you download object but you don't want to merge them, you git fetch. But git pull origin main will fetch and plus it will merge the changes. And if, as we did yesterday, we have our code now, we need to push it to the remote repository. What we'll do is that we'll do a git push origin main. So now you'll be uploading your commits to the remote repository. So maybe you can add this and try to push our code that we did yesterday using the managing the remote. So we'll switch back to our terminal. Then let's say git. Yeah, here it is. So this, what we'll do is that now I need to git remote add. I think I've gotten it right. Git remote add origin. So before we run this, maybe let's see if there is any remotes. So it has no any remote. So we'll git remote add origin. So when we run this, now you can see we have the remote. So we have the fetch and we have the push. So you can switch to that and do that before we push our code to the remote and check on the next steps. So let's see the branches. Git branch. So the branch is master. So you can say git push origin master. It seems I have forgotten this password. Let me try to recover my password. Oh, that's failed. Okay. I need to reset them, but we can continue.
If the password does not work, you can generate a token.
The PAT.
Yeah, like on GitHub, like you go to settings and then you generate a classic
The
token.
the personal access token, you mean?
Yeah, I think it's that one. You just need to go to settings and then you generate a classic token. The one that you can, it only allows you to view it only once. You should only tick repo, like only the repo, not any other thing.
I think I might use it to need it to do our workflows, so I think that's okay. Yeah, thank you. Now here we are. We have our contents on the remote. So are we good until that point? So yeah, that's how we can take our code from the remote, from the local to the remote repositories. So on the collaboration workflow, so workflow enables anyone to contribute to a project without requiring direct right access to the original repository. So one can get a personal copy of someone else repository. So you have your repository, but maybe I want to do some changes on that repository, then I can get a copy. Not necessarily you to invite me to your repository, because maybe it's a public repository as it is being done on the open source project. So the project is on GitHub. Someone get the copy of the repository. Then if there are any changes that they want to do, can do on that repository and raise a pull request. So that's how the forks work. So you fork a repository, you do your changes, and that's okay. So forking workflow procedure, that's how it works. So common on the open source project tree. So you fork, so create a personal copy, then you clone that personal copy. You create your branch from the personal copy, then you push your branch to the origin on your fork. Then from there now you can create a PR on the hosting platform to fork to the main branch on the original repository. So the maintainers of the repository, what they'll do is that they'll review your changes, and if they approve those changes now, they can merge. So if accepted, then the maintainers merges your changes to the original repository. So sync, you pull the changes from the original repository upstream to keep your fork and local copy up to date, because yeah, the way you are making, since you are making changes, also other people are making changes. So once you're pushed, the conflicts will be resolved. Then once that be resolved now, can get the copy that is existing on the remote. So that's one of the workflow that people use for the collaboration, which is the fork workflow. So then there is another one, which is the PR workflow, which is for the centralized or the shared repository. So this is common for the teams that have an access to the original repository. So you create a branch locally from your work. So then you check out to your branch, then you do changes on your branch, then you push those changes to the remote repository. Once you push those changes, you can create a PR on the hosting, on the host from your branch to the target branch. So the team members review the code in PR, leave comments, and in case they suggest changes. But also there's automatic checks. So on the CI, once as PR has been raised, then change the CI will say pipeline will run, so it do the test, the linting extra, and automatically without anyone to initiate the PR. So you make the request changes, you commit and push to your branch, then the PR automatically updates. So in case those changes have been seen by the peers or the code reviewer that these changes are maybe they're not up to the standard, then the comments will be left on the PR. So your code will not, the PR will not be completed. So you'll come and check the changes, do the necessary, and push the code. Once you push the code, then automatically they will be checked, and if they pass the criteria, then the merge will be enabled. So once the reviews are complete and checks pass, then merge the PR into the target branch. So the hosting platform usually handles the merge and can automatically delete the feature branch. Yeah. Most of the time you see on GitHub, even on the Azure repos, once you create a PR, then you can say after the PR is completed, automatically delete the feature branch because you don't need it again. Maybe in case you need to do another development, you create a new branch from the main branch. So you can digest those content for the next 10 minutes, then you come to do the lab. Because the lab will push the new changes, then since you are two, you'll share a repository. I'll invite you to my repository. It's a public repository. You share emails, I invite you to the repository. Then we resolve also some conflicts and we do the PR. So yeah, so you can take a break. Once you're back, then you can do the lab. So yeah, this is the lab that will do in the next 1 hour or so. So you can go to our GitHub and create a Git repository with the README file. So you can create a new repository. Just come here. So we can call it GitLab 1. So you can check this. And create that repository. So when you come to clone, here you are. So I'll git clone. It has readme. Yeah. So this is the content of our readme file. Here it is. So we created the repository, then we've cloned. So now we can create a branch basing on the main branch. So we said command to create a branch. Git branch. Let's say feature. So let's say git branch. So you have the main branch and you have the feature branch. So I don't want to leave you behind. So let's go back to the slides, see the steps. So we are on step number 4. We need to switch to the branch. So if you've not created the branch, you can create the branch. The command to create a branch is git branch, then the name of the branch. And then we can combine git branch, git switch, sorry, minus b, then the name of the branch. So it'll be git checkout, sorry, git checkout minus b, then the name of the branch. So it'll create the branch and switch to that branch.
I do not have you said git checkout.
Git checkout minus b, then the new branch. It is, we hate the commands here. So here git checkout minus b, then the feature. So b is for the branch.
So that command, we do it immediately after git clone, or did you do another command before that one?
So these are the commands like the ls I was trying to I first switch to the repository, inside the repository, or inside that folder, which is the git lab 1. So you clone, then you see to the inside that folder, which is there is a repository, and then you create your branch from there. So you can say git checkout. Sorry, so if you're able to see all the branches, then you can proceed to the next. So you can say git checkout to feature. So you switch to the feature branch. So you can edit the content of readme. But also you can open it with an ID like VS Code. I think with this command you should be able to open VS Code. But in our case, we'll just use the Vim. So this is the content. So you can see git status. So you can see here there's some content that was added. You can see there's a warning that was added, which is collaboration. At its base, that they added content on that file. So now we need to git add this file. Then git commit, updated readme file. So now we need to put this change, but you should be aware that we have a new branch, so we'll not be pushing to the origin main, because we added a readme file from the remote, the branch was main. But if you initialize on the local, the branch will be a master branch. So I'll say git push origin, then we have feature. And we should be able to see the content on the remote. So if you come here, so you can say had a recent pushes 41 seconds ago on the feature branch. So we can switch to the feature branch, and you can see here we are. That is updated there's an updated content. Are we on the same page there? It's okay. So another thing you need to do is on the GitHub, create a PR from the newly branched to the main. So you can see we have an option here. You can compare and create a PR. So the PR is coming from the feature to the main updated README. So the content. So also on the PR should like give some information that is meaningful to the one who will be reviewing the PR. Like say updated README file. So you can create a PR. But before creating the PR, you can see you can have reviewers. So on the reviewers, you can add a reviewer. So these reviewers will enable you before the changes have been merged, then these reviewers should first approve it. So it's here creating the PR. So if you come here, there is no any merge conflicts. So that you are ready to merge. So you can come and see maybe the commits that were done, then the files that changed. Come here. So you can see this is what changed. So yeah, you're satisfied now. You can get this. So create a merge commit, squash and merge, rebase and merge. So you can confirm the merge. You can see now we have the content here because this is what we added on the feature branch. So we have the content here. Are we good there? So the next thing now is to resolve conflicts, because that's the next thing. So you'll create another branch, modify the same file as before, then push and create a PR. So before merging, have a partner merge the conflict changes, update your branch, resolve the conflict, then complete the PR. So on our repository is, or maybe let me invite you to my repository. We do it here. Emails. My chat is misbehaving on my end. Can't open.
Same here. It's showing the same thing.
Okay.
Mhm.
So will you be able to give me your email so that we add and we do it from here?
Can share on Discord maybe.
Yeah, that's still okay.
Is it on the 26A group or personally?
The email.
Yes, like are we like pasting it on the group, like the general group, or like to we send to you
No.
personally?
You can just send it to me personally or on the DevOps engineering group, because I think there's that general one.
Can I send you my username instead? Let me see.
It's okay. You can send username.
The pink one.
So confirm if you're able to see. the repo now. Are you able?
Yes.
So now the base branch is the main. So on the base branch, create a branch from there. You can just name any, you can just give it any name. Then modify the file, the readme.file, the readme file. Then I'll also do the same. So I'll merge, then you'll need to align yourself, resolve your conflicts. So you need to get my changes first, resolve the conflicts so that you can merge your code on the main branch, and also the third person do the same. So I'll start by pushing changes to that repository.
So we clone it first.
Yeah, clone it first. So if you remember, I told you some IDs you can get this window. So it's like an I. This like an UI. So you just put your comments here and push. But on our case, we'll just use commands as we are used to. So you'll see git status, but you can also see git status using this icon here if you're using VS Code on your coding. So we are on branch feature. So git add readme, then git commit, new updates. Then now can git push origin feature. It's okay. So you can come here and do a pull request. This is a new pull request from feature to main. So you can see here we are. So we'll approve those pull requests. So I'll create the pull request. So you can review before you check on that repository and approve them so that it can be able to complete it.
Who's to approve?
You're not able to approve?
I don't see I just see ready to merge and then merge pull request. There's no like approve. There's add your review.
Pardon?
There's an option for add your review, and then there's also straight to merge pull request.
So you don't have a place to approve.
Two pending reviews. Maybe just share my screen. So I can see this. Are we supposed to add our reviews here or?
Scroll up. Click add your view.
Submit or ready to
On
merge?
the drop down. Approve.
Okay.
Yeah, I can see you approved. That's okay. So now you can pull in case you have already cloned, you can pull the changes. So you can git pull so that you have the changes, then create a branch from there and do the changes. Then one will push before the other, or before that. Before that, from the because you had already you had already cloned. Maybe if you had already cloned, what you'll do, you just create a branch from there, then change the same file that I've changed, so that when you push, you'll experience the git merge. Or when you create the pull, when you create a merge, you'll get the conflict, then you resolve those conflicts. So because I have already pushed changes, when you want to push the changes based on what you had pulled before, if you had already pulled, you should experience the conflicts.
Wait, so what have you said? I had already cloned before you did all of that. So I
before you
had
did
cloned.
the. It's okay.
Yeah,
So
I had
from
already cloned.
that clone, as on check out to branch main. Then on that branch, create your branch from there and modify the readme file on your end. Then push that branch, then go to GitHub and create a pull request. So when you create that pull request, you are likely to face a merge conflict because the most recent commit that I've pushed, you don't have on your file. So then you resolve that merge conflicts.
So create a pull request
Yeah, on
and
GitHub,
add
create
your
a pull.
reviews.
You
Okay.
can add reviews, or it's not a must that you add reviewers. You can just you'll see the merge conflict. I think you'll be able to see merge conflict if you did it. They had the most recent commit that I've just pushed when you reviewed. So then you just resolve that commit or that conflict.
Okay.
Yeah.
Resolved and merged.
Pardon?
I've resolved and merged.
Oh, it's okay. Let me check. It's okay. Here it is.
question.
Yes.
Mine is asking me for like authentication. So if I'm creating a token, do I do it from my GitHub or the repo that you created or something?
Yeah, do it from the repo because that's the repo we want to push to.
So from yours.
Yeah, because that PAT will be yours because it will be created
Okay.
against your username. Are you able to push?
I'm almost done.
It's okay.
is it supposed to ask for authentication twice?
When pushing or
Yeah.
so you push, then
Um,
it's asking again for
Yeah.
another.
Yeah, so I need to generate another token. So that's gonna take a lot of time.
You don't have it on your clipboard.
Oh, sorry. I had muted. I'm supposed to install the thing for copying and pasting because we're still doing it in my other class. So that I have to type the stuff.
Okay,
Yeah, so it's gonna take time.
it's okay. So, but yeah, ensure you are doing that so that you can be able to resolve the merges, the conflicts that
Okay.
will that have resulted from there. Tomorrow's
Okay.
class will start with that so that we ensure everyone is able to resolve the conflicts, and then it'll
Mhm.
see so that we can try to resolve also on local machine before we do end push, so that by the time you are pushing a clean code, so the reviewer will not be experiencing the conflicts, or you yourself resolving conflicts on GitHub rather, but resolving the conflicts on your IDE before you push the code while it is clean. So that is
Okay,
okay.
I'll have it done before tomorrow.
It's okay. So we are set. Thank you all for the time. Let's meet tomorrow at the same time again. Wish you a nice time and a nice day. Stay wherever
Can
you
you
are.
share